All right. Well, we got 2 minutes after the hour, so I think we'll get started. We've got quite a few attendees here this morning, so I want to thank everybody for taking time out of your busy day to join our webinar on manufacturing under an Appendix B program. Matt Schustrick here at Paragon, Vice President of Sales, and today I'm joined with Tracy Bolt, who's our Chief Nuclear Officer. Tracy's been with Paragon for over 23 years, and he's head of our entire quality department. So thanks for joining us today, Tracy.
Thank you, Matt.
So just bringing up a couple quick housekeeping notes here. We've got everybody on mute for the duration of the webinar. Please use the Q&A button or the chat feature, either one, to submit any questions you have as we go through the webinar today. We'll make sure and address everyone's questions at the end. Also, we're recording this webinar, so once it's over, you'll be sent a link to the recording, and that way you can send it out to maybe some of your colleagues that weren't able to join today. So I'm just going to go over the agenda for today's webinar. We'll start with a brief overview of who Paragon is for people that may not be familiar with us. Then we'll go on to some questions really about the how, the when, the why you'd manufacture products under an Appendix B program. We'll look at what our program consists of to manufacture those parts under Appendix B, and also examples of different product lines that fit under that particular topic. So first, I'll start by introducing, who we are, Paragon. So we're the largest non-OEM nuclear-focused business in the world. And you can see on the right here our areas of expertise. So we specialize in commercial-grade dedication, mechanical and electrical reverse engineering and custom design, equipment qualification, I&C repair and reverse engineering, and also alternate sourcing. So manufacturing under Appendix B is really a cross between custom design, equipment qualification, and in some cases, reverse engineering. So we've got over 170 employees here at the Fort Worth, Texas facility. Paragon was created from ATC Nuclear in 2017. And earlier last year, about almost a year ago, we acquired Nuclear Logistics. We're audited by NIAC, NUPIC, the DoD, and DOE. And we've got an ASME Section 3 program. So we've got our N, NPT, NS, and NR stamps. So with that, I'm going to turn it over to Tracy to talk about, how Paragon manufactures under Appendix B program.
Thank you, Matt. And I really appreciate everybody joining today. It's an honor to be able to talk to you. And so when we look at the first question, can you manufacture under an Appendix B program without performing dedication? It seems this question has actually come up a lot. And if you didn't know, I'm on the NQA1 subcommittee for engineering and procurement. And this is actually a topic that's come up, several times within our group, and where some people still just they haven't gotten a grasp on, can you still manufacture under an Appendix B program without doing dedication? And so, you have a lot of guidance in the industry that cover dedication. We have processes, we have a whole section in NQA1 that talks about dedication. But what people fail to realize is that, NQA1 has 18 sections that talk about how to control your Appendix B program. And so when you get back to the original definition of a basic component, it talks about, basic components are components that are designed and manufactured under a quality assurance program complying with Appendix B to Part 50. Or they're commercial grade items that have successfully completed the dedication process. So the first thing that you have to have is an Appendix B program, even if you want to do dedication. So manufacturing under an Appendix B program is your first option. Next slide, Matt. So when you look at the definition of a basic component, you're talking about the specific information of designed and manufactured under an Appendix B program. So what does that really mean? When you apply it to basic components, it actually means, are you controlling it under your program? Not only just manufacturing and controlling the design, but you're controlling the whole controlling the whole process. And again, having a basic component without dedication was the original intent of the Appendix B requirements. So when would you manufacture as Appendix B versus performing commercial grade dedication? Well, you're going to have, we already know we have obsolescence issues within the utilities. There's components that are no longer available. Either the original suppliers dropped their programs and they only supply commercial grade, or they don't even support the product line anymore. And so when you have those obsolescence issues, the only choice is we have a couple of choices, but you can reverse engineer it under your Appendix B program, or you can find an alternative component. But being able to reverse engineer an obsolete item and then manufacture and build it under an Appendix B program is one of those better options. If you have an ASME Section 3 program, your only option is to have to manufacture under Appendix B. So dedication doesn't even come into the realm of code items in regard to ASME Section 3 components. You might have a new design. The plants are upgrading and you want to have a new design in the system, and you may need to just develop that, control the design and the manufacturing under the program, because there's not an item that is actually available in the commercial area. Some of the assemblies that we manufacture here under our program, we do motor control center cubicles and power supplies, circuit boards of various types, battery chargers and voltage regulators, just to name a few items that we manufacture under our program. So our program is written to comply with 10 CFR 50 Appendix B and NQA 1. And again, this is the first requirement. If you don't have an Appendix B program, you're not going to do dedication. But the thing is, OEMs were providing nuclear grade items to the nuclear industry before commercial grade dedication even had a definition. So when you get back to can you still manufacture and supply under an Appendix B program without dedication, again, that answer is yes. So in regard to Section 3 items, again, you have to have a 10 CFR 50 Appendix B program, and the code actually requires that you utilize NQA 1 in order to meet those. Commercial grade dedication is not an acceptable method of accepting items or material for code items. Pressure boundary items, they're manufactured from qualified material in accordance with the code. Any material that's used that you want to, if you want to utilize unqualified material, there's a whole process for that within the code, and dedication is not part of it. So manufacturing under 10 CFR 50 Appendix B, when you have items, whether you're going to reverse engineer, or maybe we have a commercial item that needs a modification. We've had many items in the past where we get switchgear or motor control center sections, any type of large equipment that we might be working with the commercial industry to produce the basic product, but the plants need the items to work a specific application. And the commercial industry, they're not tuned and they're not set up to cater to the nuclear industry anymore. And so where we come in is we'll take that basic item that the commercial line puts together, and we'll make the necessary modifications to provide it as nuclear grade. And all of those modifications were involved with controlling the design and doing any additional design verification activities that are required for that item. So there's been, like I said, there's been a number of items that we've gotten in that, the items have to withstand a particular level of a seismic event at the plant. So as part of that testing, we'll look at that item. Even before we start the test, we'll look at the item and see, is that structure of the equipment, is it adequate to be able to withstand the levels that the plant needs for its application? And we'll go ahead and, we'll evaluate it and determine, okay, well, we need to add some seismic supports, or we need to build a new base, or we need to add some structure to the item. And in order to do that, we have to control that process. You don't dedicate welding, you don't. And so those processes that are controlled and stated in Appendix B and NQA1, control of special processes, we do that under our program. And so all of the welding, the designs controlled in regard to creating the drawings and the layouts and specifying the required materials, all that will be verified in our facility, whether we have approved suppliers that are providing some of those raw materials, or we're having something built somewhere else, and we'll verify and monitor those activities. It'll still be controlled under our program, but we'll bring that in. We'll add those items, those modifications to the equipment, and then we'll perform the design verification tests in regard to any seismic or whatever qualification activities are required. But all of those activities, all of the items that are put in, the changes, all of that is documented under our program and maintained as part of the design of the item. Once those items have been completed and inspected, verified, it'll go through a factory acceptance test to ensure that it meets all the required functions. Next slide, please. So how is it controlled in accordance with our Appendix B program? So like I said before, the 10 CFR 50 Appendix B, there's 18 criteria to base your program, whether when you talk about order entry, your organization, design control, controlling your suppliers, controlling your material, the test equipment that you use, qualification of your personnel, document control, all those elements are a requirement for the program. And when we're producing a nuclear grade component under that program, those elements are required to maintain that item. So again, whether we're buying a commercial item and dedicating it, or we're actually designing and building an item under our program, that those elements are utilized. So again, when the documented controls, we'll have the required procedures and work instructions to control that process during manufacturing, and all the implementation of the controls with our documentation provides that objective evidence that the item meets the design requirements. Next slide. So one example that we're going to talk about is the NCN type batteries that we've been providing for many, many years. This particular battery is one that we've been involved with, like I said, for over 25, almost 30 years. And you cannot get an NCN type battery commercial grade. There is a similar flooded cell battery that can be purchased as non-safety, but it is not we don't take that non-safety battery and dedicate it for safety related use. The NCN type batteries we have a process in place at the manufacturing facility where we have individuals that live in Fort Smith, Arkansas, that work at the manufacturing facility every day. And so, excuse me, when we have an order, those batteries are manufactured to order. So if a plant needs a string of batteries, we don't just pull them off the shelf. They're actually manufactured for that plant. And all of the manufacturing processes are monitored by our employees. We have the QA controls over the manufacturing, and we do that so that we ensure that the batteries are still maintained and manufactured in accordance with the design that was originally qualified. So these are they're very intricate design. There's the manufacturing process is one that needs to be monitored to ensure that they're equivalent to those that were originally qualified. So we're embedded into that process. So where you'd have you can have some batteries that can be dedicated, but this particular line is not. Another thing that goes along with the batteries where we have the Appendix B manufacturing is when we supply the racks. So you can see in that top photo, the battery racks that are there. We'll, if need be, we'll also provide the necessary battery racks for storage in place where they're going to be used. And so those battery racks also are manufactured under our Appendix B program. So again, like I said before, you don't dedicate welding. It's a special process that has to be controlled. So we'll design the battery racks in accordance with the necessary requirements to maintain its seismic levels. And we've also had racks that we've actually put on the table with batteries and actually shook. So we have those qualified designs, and we'll build those racks in accordance with our program, and it'll all be controlled. So the racks aren't dedicated; they're actually manufactured under our program. Now there might be individual components like the strut, the hardware, the other components that are attached to it, and those items can be dedicated and would be dedicated. But the racks themselves with all the welding, we would actually produce that under our program. Next slide. So another area where we've got a hybrid approach, where we do both dedication and manufacturing under our program, is an area of motor control center cubicles and other electrical assemblies. You have a combination where we have components that are going to be installed into an assembly, and in order to develop and verify the critical characteristics of the components that are going into that safety related assembly, the only real good way to verify those is to actually test and dedicate those items prior to installation. You take a circuit breaker, for instance, that if you need to verify its performance characteristics of a trip curve, there's a special way that you need to test the breakers to ensure that you're going to test it properly. You need to have the right length of wire when it's connected up to the high current test set. And if it's installed into the bucket, it's really hard to get that consistent results when there's a set standard in how you need to test those items. But again, the testing a thermal overload relay on a starter, and other items within the bucket, it's a lot easier and more efficient to actually test those and dedicate them prior to assembly than trying to test those characteristics after they're installed. And fuses, another item where it's a lot easier and more effective to actually test them, unless you're just doing a continuity check, but that's really not effective. So again, after all the items have been dedicated and accepted, they'll then be installed into the assembly, where after all the checks have been completed, inspections have been done, we'll do a final factory acceptance test and ensure that the actual function of the bucket itself is operating properly, fit up and everything actuates. We got the right, the right electrical responses that we need, and contacts open and whatnot. Next slide. So this is a really good example of how versatile we are at Paragon. Excuse me for 1 second. So the chiller in the middle, this is a really extensive project that we've had here in the past, where it really challenges all the aspects of our program, where there are digital controls. There's items on the chiller that are, just strictly safety related. And then it also consists of ASME Section 3 components, heat exchangers, condensers, valves, piping. And it's a complete assembly that we produced that really, like I said, it challenges all aspects of our program. But all of that was controlled under our Appendix B program, and it was supplied as safety related and Section 3. Other examples, you see just different valves that we've produced and controlled and manufactured under our program, along with an example of a heat exchanger. There's many others, but we could have slide after slide of different components that we've done under our Section 3 program. So another aspect of our program is the instrumentation and controls, where we'll manufacture these items also in accordance with our Appendix B program, and they'll be built as nuclear grade, and they're not dedicated. So these items are not available commercial, and they're actually manufactured under our program. We did a reverse engineering of the average range power monitoring system and developed, I think this particular system consisted of about 11 circuit boards, a couple of power supplies, and a meter panel. And so we did a complete reverse engineering of this, and these are drop-in replacements to the existing for the existing system. And it was developed in order to reduce the amount of maintenance learning curve for the maintenance techs in the plant, where they'd be able to take this new board that we reverse engineered and just drop it into the system, and it would work the same as the original. But this is again another element where we did a reverse engineer. We controlled all the design, the drawings, the manufacturing. We might have subcontractors that do specific work, maybe create the bare board, but the manufacturing and assembly is all done at our facility and controlled by our personnel. So another good example of Appendix B manufacturing, and just so many different things that actually need to be produced under our program that you just can't get these items commercial grade. Next slide. Oh, well, I'm sorry. It looks like I'm at the end of my presentation. I really appreciate the time from everybody. And at this time, I'll turn it over to Matt Schustrick, and he's going to give you some information on our PEAKS database.
Well, thanks, Tracy. Yeah, I appreciate, that overview of our program and how things are actually manufactured versus, dedication, and kind of the distinction between the two. So great job. Yeah, before, while I have everybody on the phone, I just wanted to kind of share our PEAKS database with anyone that maybe hasn't seen it at all. And we'll actually stay on that last example here that you just showed on the APRM cards. But what is PEAKS? PEAKS is an online database that you can use to search for any of your parts and needs. So whether you're supply chain personnel, or in procurement engineering or system engineering, and maybe you came across a obsolete item at your plant that you're looking to go out and get. The database is filled with 9 million part records that are updated from they're updated regularly from plant inventory. So it also has Paragon's IP in it. So, when you search, you'll also see anything that Paragon's maybe repaired or can repair, reverse engineered, or dedicated. So it's a really, really neat place to look for your parts. So you go to paragones.com. And then in the top right toolbar there, you'll punch in your part number. So in this for example, as we talked about the APRM card, or if you have a system like APRM and it's obsolete, you can go in there and maybe you're searching for a specific part number because you have a failure, or you just want to see if, there's a obsolete solution available. In this case, you would type in this specific part number, or even simply search APRM, hit search. And when your results show up, like you can see here, you can see all the ways Paragon can help, sourcing that specific part or in obsolete solutions. So as you dig into it, you can see what all solutions are available. In this case, you can see we've repaired this item. We've also reverse engineered it. We've dedicated. So we must have, gotten some surplus cards that were out there that we ended up doing dedication on. But, say you're in a bind, you're in an LCO, you need a part quick. You can see that there's overstock available out in the industry. So, it's a really good place to go and look for your parts, look for obsolete solutions, and it's all in one place. So, I just wanted to share that with everybody. So wrapping up, as you can see, some key takeaways here, the renowned question, an answer of yes, you can manufacture under an Appendix B program without having to go through a complete commercial grade dedication. When defining a basic component, the design and manufacturing are controlled under 10 CFR Part 50 program, as we do here at Paragon. So there are many different components that can be manufactured under Appendix B, such as some of the examples that Tracy went over, along with a laundry list of others that we do every day. And, manufacturing under Appendix B program consists of a cross between custom design, equipment qualification, and in some case, like we saw, reverse engineering. So with that, I'll turn it over to the attendees here to see if we have any questions, which it looks like there may be one here. So Tracy, if you implement improvements, do you consider that it remains reverse engineering or is it re-engineering?
Well, I would, when I look at that, it kind of gets into semantics, but when you're doing a full reverse engineering, are you doing black box technology, or are you trying to duplicate what was actually there part by part? A lot of these items, it's tough because the items that were utilized, 30 years ago, they're no longer available. And so you have to come up with alternatives and do those evaluations of those individual components that have to replace those items that are no longer available. It's a fine line. You're doing the reverse engineering to identify your inputs and your outputs so that you can meet the design requirements. But you have to, that's one of those things also, you have to really have good communication with the end user because they know the specific application, they know information that we may not have when we just have the component in front of us. There might be particular loadings that we don't see in a test environment that it's actually seen when it's installed. So there's a lot that goes into it. So again, communication's key when you're doing the reverse engineering.
Okay, thank you. So we've got another question on reverse engineering or re-engineering. So does reverse engineering or re-engineering require approval, licensing approval by safety authorities? Would you have
as far as safety authorities in regard to like if it's for Canada and you have CSA approvals, if the plant has UL requirements that they need to meet, then I would expect that yes, those items that are being reverse engineered or re-engineered would need to get those same approvals if that's your licensing requirement. I do know that we have generated, or we've built equipment for Canada and electrical equipment that we have to, submit to the Electrical Safety Authority for them to inspect and actually certify before it can be supplied to the plant. So the answer to that is yes, but it all depends on the requirements of the end user.
That's good. So another question, how do you manage surplus spare parts? Do you ask all of the qualification files, file all the documents related to them? So regarding spare parts, so we treat your surplus inventory. So we treat surplus as non-safety related or commercial components that will go through a dedication or qualification process on their own. Unless the surplus spare parts are stored in a level B storage and we've got, the complete procurement documentation package on it where, we can transfer that status. But most of the time, the surplus items we buy are commercial grade, and then we upgrade them, either perform dedication or qualification on those items to upgrade them to QA level 1. And another question, what's the average time to reverse engineer a simple circuit board? Well, that's a loaded question.
I was thinking the same thing.
Simple is a relative term. I will say that, it can range from, 4 to 6 to 8 weeks, depending on, what your level of simple is. But it's hard, it's pretty much during a case-by-case basis. And it's also situational. So, if it's something that is needed emergently at a site, like we had reverse engineered some boards, some turbine cards for Grand Gulf, and we did that in 2 weeks. But that was pretty significant round the clock support. But the site needed it right away. It was something that they were offline, so we kind of ran with it. But like I said, it's all relative. But if you have something that you're looking, obsolete, and you're looking to get reverse engineered, please send it over to either info@paragones.com or either to myself or Tracy, and we'll take a look at it for you. Absolutely. So Tracy, is meeting 10 CFR 50 Appendix B and Section 3 requirements sufficient for European customers, or do they sometimes have additional criteria that have to be satisfied in addition to the NRC and ASME requirements?
The experience that I have had with European customers has been that they do accept our 10 CFR 50 Appendix B and Section 3 requirements. They've accepted our program, and we haven't really had any issues with that. So for the most part, again, we haven't had any issues meeting the customer requirements with our current program.
Okay. And does the PEAKS database include reference to the qualifications? So in PEAKS, you will be able to see if an item was ever qualified by Paragon. So in it, whether it was harsh or mild, it'll show up. So, it's really plant specific on the qualification portion, but if something's already been, harsh qualified for one plant, typically we can use that, right, Tracy, for others. So, it will definitely show up in PEAKS if it's something that we have dedicated before, and also if we've qualified it, and it would specify whether it has been qualified for mild or harsh environments.
Right. It's just not going to list this in the standard PEAKS format. It's not going to list a specific qualification report number. It'll just indicate that it has been qualified.
Correct.
So it would still need to be evaluated to determine if the qualification status of that item actually meets your specific requirements at your plant.
That's right. Okay.
Hey, Matt and Tracy, this is Ty. There's one question in the chat, so I'll ask it. I think Tracy, you can answer it probably. So, how do we check for fuses or breakers before installing them into a basic component in case that those fuses or breakers are commercial? Do we dedicate them before that? What's our process?
Yeah, so with fuses and breakers, starters, we actually dedicate those before they're installed. So we have kind of our production line where we've got a testing lab where all the breakers, fuses, relays, transformers, starters, if they're being purchased for an assembly, they'll go into the production lab area where all the testing will be completed on those. And then the motor control center buckets, they'll be populated based on the bill of material. They'll be populated with particular part numbers, and they'll fill those bins with the parts that are going to be installed after they've been tested. So yeah, the fuses, they'll do a melt on the lot, a hold in on a sample, and resistance checks. If there's any other critical characteristics that the plant wants, that they feel is necessary, like dimensions or anything else, we'll verify that prior to putting them into the assembly. Circuit breakers, same thing. We'll do the hold ins. We'll do the trip testing. And actuation, verify that the breaker is operating properly, and it passes all the dedication requirements prior to being installed.
Good. We've got one more in the QA. So Tracy, what is typically more cost effective? Commercially grade dedicating a component or manufacturing under 10 CFR 50?
Well, when you talk about cost effective, it's really, what do you have to do? Because if an item is commercially available, then it's going to be, we're not going to go out and build a molded case circuit breaker, right? We're not going to build a molded case circuit breaker under our program. So we have no choice but to actually dedicate that. It all depends on the item. When you look at the equipment, and how does it have to be produced? So when you talk about cost effectiveness, everything takes time, whether you're going to test it or you're going to build it and control it. The fact is, our program is already set up to be able to produce things under the design controls that we have. It's a really subjective question. It's hard. That's one that's hard to answer. But I don't know. I'll go back to Paul Prescott's answer. It depends. It depends on what the actual item is, to whether you can actually, can you actually dedicate it, or do you need to produce it under your program? The fact is, it still takes time, and you still have to control it.
Yeah. So we pretty much take the path of least resistance, right?
Right. Yeah. We'll always try the most effective and efficient manner to save the plant. We want to save the plant's money, and we want to save the time that we have here, because time is money.
Yeah, I think Tracy, it's often the case that if you can find an item commercially available that provides the functions that you need, that will, generally speaking, be much cheaper option than designing an item from scratch. But if you have an item that you can't buy commercially that will meet your requirements, modifying that item may cost more than just building it under the Appendix B program as a manufactured item.
Good. We've got one more in the Q&A. If I use Rapid Parts Mark to look for a part, well, I have to use your Peaks database to check to see if you have it in stock. So we do feed all of our data into Rapid as well. So you will be able to see that in Rapid through parts. You just won't be able to really request a quote for anything, which is where, if you're in the Peaks database, it's a direct line to our alternate sourcing team and our inside sales team to get you a quote right out of that database. So, but you will be able to see in Rapid if it's available.
Said has another question.
I'm sorry, go ahead, Tracy.
Said has another question. It says, what is your preference in case of reverse engineering? Would you like to build a prototype first or not. Simulating the field conditions could be a challenge, so making a prototype and testing it in the real field. Absolutely, we always want to have a prototype before we go to production. There's always things that you're going to identify when you're doing your testing, doing the qualification tests that we perform. If it's an item that requires EMI RFI, we absolutely want to build a prototype to work all the bugs out that might be there, add any filters or MOVs or anything that needs to be added for that kind of protection. And then also, we want to have the prototype completed if there's any seismic requirements. So if you have to add any structural support or how the components come together, we want to make sure that we have all that down and properly designed and verified before we start building a production unit. And if it's possible, absolutely, that again, it goes back to the communication with the customer as far as being able to put it in the field and verify it. Or, sometimes we've actually been able to supply the prototype to the plant and they're able to do their bench testing, or they might have a safety related, or a non-safety training unit that they could put the equipment in and verify that it operates properly. But absolutely, we would always want to have a prototype and do as much simulated testing prior to building the production units. Another question just popped up about mechanical items. Yeah, as part of our Appendix B program with our Section 3, we've done some reverse engineering on a mechanical valve. We had a butterfly check valve that we had to do years ago. And, it's one of those things where the original manufacturer had it was like a 50-week lead time to be able to help the plant out. And they gave us the opportunity to produce another valve of that same type under our Section 3 program. And we were able to work with our approved suppliers, our foundry that we had, and we were able to produce this. I think it was a 12-inch or 18-inch. I can't remember all the specific details. I just know it was fairly large. We were able to produce the valve in about 9 weeks, and really helped the plant out. But it goes back to having the design documentation. So the plant had the design report. They had all the design information. They also provided us a valve to work with, so that we were able to do all the dimensional verifications in producing the new valve.
Good. Thanks, Tracy. That looks to be it for the questions. We can hang around here for another minute or so.
I really appreciate the questions.
Yeah, I know. Some good ones too. Around here just for another few seconds to see if anybody else has anything. Got it. Thank you. You're welcome, Gerardo. Okay, looks like everybody's done. So we appreciate everybody, taking the time out today. So we'll make sure and get this recording out to everybody that was on here, and feel free to send it out to anybody you think might be interested. So thank you, everybody from Paragon, and we will talk with you later. See you next time.
All right. Thank you, everybody.